my name is Joanna Quizhpe and my partner is Leslyn. We worked on section 4.2, which is cooling and mixing, and we did question 5. Our problem was an object with initial temperature 150 Celsius is placed outside where the temperature is 35 Celsius and its temperature at 12:15 and 12:20 are 120 Celsius and 90 Celsius respectively. So we have two parts of the problem, which is A and B. For A, we're going to be solving is at what time was the object placed outside? And for B, when will its temperature be 40 Celsius? So what we did first was highlight the important keys, which was 150 Celsius, 35 Celsius, and 120 Celsius, and 90 Celsius. And then we underlined 12:15 and 12:20 since these are the number that we're going to be using to solve our problem. Okay, so suppose T is the temperature of the body at any time T. So given that T0 equals 150 Celsius, which is our initial temperature right here stated on the problem. And our T is equals 120 Celsius, which is our temperature of the body at 12:15. And T plus 5 equals 90 Celsius, which is our temperature of the object at 12:20. Now our S is 35 Celsius, which is our temperature of the surroundings. Now that we have everything written down and making it more clear, and when we're substituting, everything's clear on where to substitute in our formula, and everything's color-coded, so it can make our lives easier. So now we're starting problem A. So by using the Newton's, hope I'm saying it correctly, law of cooling, we have that. So the formula of the Newton's law of cooling is this right here. So we substituted Ts, which is 35, and T0, which is 150, minus Ts again, which is 35, and parentheses e to the negative kt. Now it equals, which gives us 35 plus 115 e to the negative kt, which that will be our answer for T. So I labeled it as 1 so it could make my life easier and make your guys' life easier to understand better. So then we substitute T to 120, which was given to us in the problem. So 120 equals 35 plus 115 e to the negative kt. Now that we solved that, since we subtract 120 minus 35, it will give us 85. And to make our lives easier, I just moved it to the right and moved the 115 e to the negative kt, just so it could be better understanding. So that will give us negative e to the negative kt equals 85 over 115. You could also write it as a decimal, but I prefer to write it as a fraction just as of right now. So I also labeled it as 2 because I'm going to be using it later in an equation, in a formula. So now we're going to use T plus 5, which is 90, which was given to us as well. And then we're going to use the equation that we saw for T here, which is 35 plus 115 e to the kt, which is 1, which is why I labeled it. Now we're going to use it here. So it will be 35 plus 115 e to the negative k, parentheses t plus 5 equals 90. And when we subtract 35 on the right will give us 55. So 115 e to the k parentheses t plus 5 equals 55. And then that will give us e to the negative k t plus 5 equals 55 over 115, which I also labeled it as a 3 and as a triangle because we're going to be using it on our next step. Now we're going to divide, like I said before, I labeled 2 and 3. So we're going to divide 2, which is 85 over 115, divided by 55 over 115. And so we're gonna use, so we're gonna divide it, which will give us 17 over 11. So 1 divided by e to the negative 5k equals 17 over 11. Then that will give us e to the 5k equals 17 over 11. And of course, we solve it, which is 5k equals ln parentheses 17 over 11 parentheses. And of course, we divided, which would give us k equals 1 divided by 5, ln parentheses 17 divided by 11 parentheses close. And then that our answer would give us k equals 0.0871. Then we're gonna be substituting the value of k in 1. We get, so we're substituting the value of k in 1. So we're gonna use, again, now this equation that we got, our answer, and we're gonna substitute k, which is this right here. We're gonna be substituting this, which is 0.0871, which is our k that we got before. So our answer would be t equals 35 plus 115 e to the negative 0.0871 t. So again, I labeled it as 4, just so we have a better understanding. Now substituting t equals 120 and 4. So we're going to use this equation once again, and we're going to substitute t, which is 120. So then we divide each term in 115 e to the negative 0.078 t equals 85 by 115, and then we simplify. That will give us e to the negative 0.0781 t equals 1723. Then we take the natural logarithm, I'm sorry if I'm pronouncing it wrong, of both sides of the equation to remove the variable from the exponent, which would give us ln parentheses e to the negative 0.07816 equals ln to parentheses 17 divided by 3. Now we expand the left side, and it will give us negative 0.0781 t, which equals natural logarithm parentheses 17 divided by 23, and then we divide each term in negative 0.781 t, which equals ln, which is natural logarithm, parentheses 17 over 23 by negative 0.781. So we're going to divide this, so it's like a better understanding, and then we simplify like we did before, which will give us t equals 3.87, and more numbers was given, but I just simplified to the second decimal, which is approximated 4 minutes. So if we do, so in our problem, they give us 12:15, correct? So now we're going to subtract 12:15 minus the 4 minutes that were given to us, which will give us our answer, which is 12:11. And that will be our answer for A. So our answer would be 12:11, the object placed outside. Now we're going to Now we're gonna solve for B. So for B to find T, so T equals 40 Celsius, and then we put T equals 40 and 4, which is this again, our equation that we solved for. So we get, of course, T, we substitute T, which was 40 right here. So 40, and then equals 35, which was given to us already. 35 plus 115 to negative 0.871. Sorry, that was mixed up there, but yes, it's 0. I'm sorry. That's, yeah, negative 0.0781 T. Yes, that's correct. Then our answer would be 115 e to the negative 0.0781 t equals 5. That's when we move all terms not containing t to the right side of the equation. That's what we did there in order to get to this step. And then now to get to the next step, we divide each term in 115. We divide this one, 115e negative 0.0781 equals 5 by 115 to get rid of the 115 on the left side. And then we simplify, which will give us e to the negative 0.0781 t equals 1/23. Now it gives us ln parentheses e negative 0.0781 t equals ln parentheses 1/23. And what we did there was we took the natural logarithm of both sides of the equation to remove the variable from the exponent. And then again, we solved it, which was negative 0. Well, we expanded the left side, so it would be negative 0.0781 t equals ln parentheses 1/23. Now we divide negative 0.00781, and then we simplify as well as we did before, and that would give us our answer, which gave me t equals 40.14147, which I again just approximated to the third place decimal, and that gave me approximately 40 minutes, so I rounded to the whole number. So after t equals 40 minutes from the initial time, 12:11, the temperature would reach to 40 Celsius. So our answer for B would be at 12:51, the temperature of the object is 40 Celsius. And that's all that we solved for today. So